Hey everybody, in this one we're going to continue rational exponents, but now we're going to throw some more exponent properties at you. So we're going to continue tying all of these things together. So if you want to pause the video here to jot down these examples, by all means go for it. But what we're going to do now is we're going to start seeing rational exponents maybe hidden within parentheses or maybe on the outside of parentheses, and we have to apply our other exponent properties onto them. So let's start off with this first one here. We have negative 27 times x to the negative 9th, all raised to the 1/3 power. So now we have the choice. We can either deal with the inside terms first, right? So if I wanted to, I can move that 9 to the bottom and then distribute in that exponent. Or we could distribute the exponent in right away and then simplify. It's entirely up to you. Me personally, I like simplifying the inside first. So what I'm going to do is rewrite this as negative 27 over x to the 9th. All of that raised to the 1/3. So really all I did is just got rid of a negative exponent. So now this exponent of 1/3 will affect every single exponent inside. So I'm going to have the cubed root of negative 27 over x to the power, let's see, 9 times 1/3. Well, that's really just 9 divided by 3, so that would be x cubed. So now we evaluate. The cubed root of negative 27 is negative 3 over x cubed. Done. Second one, we have negative 32 x to the 15th, all raised to the 1/5 power. So there's nothing inside for me to simplify, so we're going to bring in that 1/5. So I've got negative 32 to the 1/5 power. What number times itself 5 times will be 32? Well, that'd be a negative 2. And then we have x to the power of 15 times 1/5. That's really 15 divided by 5. So that'd be 3. Negative 2x to the power of 3. Number 3 here. We have x to the 1/2, y to the negative 2/3. All raised to the negative 6th power. So this one might have a handful of negative flipping and floppings that we have to do. First, I'm going to simplify the inside. You guys know me. So x to the 1/2 over y to the 2/3. And then what I'm going to do is change this negative 6 to a positive 6. And in order to do that, I just take the reciprocal of whatever the base was. So I've got y to the 2/3 over x to the 1/2. So I'm going to distribute a 6 into the exponents here. So on the y, we're going to have 2/3 times 6. Well, 2 times 6 is 12. Divide that by 3, I get 4. Over x to the power of 1/2 of 6. Well, 1/2 of 6 is just 3. Next one. X to the negative 2/3, y to the negative 1/3. Again, I like to simplify the items inside the parentheses first, so I'm seeing negative exponents. I'm going to flip those around so that they become positive. So I've got y to the 1/3 over x to the 2/3, all raised to the 15th power. So the new exponent on the y is 1/3 of 15. So 1 times 15, divide that by 3, I get 5. 2/3 of 15. 2 times 15, divide that by 3, I get 2 times 15 divided by 3 is 10. There we go. Lost my train of thought, folks. All right. Just a few more. In the interest of time, let's try to focus on, we'll do number 8. All of these are relatively similar to what we've just done, and the completed notes are online. We'll do number 8. We'll talk through that one. So number 8, we have 8 x to the 6 over 27 y to the 9th, all raised to the 1/3 power. There's nothing inside for me to simplify on the inside, so I'm going to bring that 1/3 power onto every single exponent inside this parentheses. So 8 to the 1/3, x to the 6 times 1/3 is 2, 27 to the 1/3, and y to the 9 times 1/3 is 3. All that's left now is evaluate. The third root of 8 is 2, so 2x squared, over the third root of 27, because remember, the 8 to the 1/3 is really the third root of 8, and then third root of 27. That'll be a 3y cubed. All right. We'll go number 10 on this next one here. Again, these are all going to be similar styles of problems. The solutions are available to you, posted to Classroom. Number 10, we have the fourth root of x to the third all over the eighth root of x squared. So what we want to do is be able to use our exponent properties. All right, if I could think of this as x to some power over x to some power, it would be a heck of a lot easier to use my properties and subtract those exponents. Well, the first one, I'm seeing an index, I'm seeing an exponent, that would be x to the 3/4. The denominator, again, index and exponent, would be x to the 2/8. Well, I know that 2/8 down in the bottom there, that can actually reduce down to 1/4. So now if I've got x to the 3/4 over x to the 1/4, I'd find the difference in those exponents. They already have common denominators, so that's awesome. It's going to be x to the 2/4, which we know is 1/2. If they wanted me to write that as a radical, I'd say the square root of x to the first. All right. Now let's get into some challenge problems and we'll call it a day. Again, if you want to pause the video here, by all means, go for it. Okay. So for the first one, we have 2 to the 1/2 power times 32 to the 1/2 power. We can't really use our exponent properties here because the base numbers aren't the same, which is kind of a bummer. Now, when we're dealing with this, what you want to be on the lookout for is, can I take the larger base and rewrite it as the smaller base raised to a power? What I mean by that, is it possible for me to write 32 as 2 raised to some power? And yeah, we can. 32 is really 2 to the 5th power. So you're going to take the larger of the two bases and see if you can rewrite that as the smaller of the two raised to a power. So all I've done is change, instead of 32, I wrote that as 2 to the 5th. So now let's use what we know. We can multiply in that exponent, so I'll have 2 to the 1/2 times 2 to the 5/2. I'm seeing the same base being multiplied, so I'll add those exponents. 1/2 plus 5/2 is 6/2. And that's just 3. So this is 2 to the 3rd, which is 8. So all of that nonsense there turned into a nice clean number 8. All right, number 2. 3 to the 1/4 times 27 to the 1/2. Again, we don't have the same base, but we want to have the same base number. I've got a 3 and a 27. So what I'm going to do is I'm going to take the larger of the two and see, is it possible to rewrite that as 3 to some power? Well, yeah, I could say 27 is just 3 cubed. So now that's the only thing I'm going to change from that first step. Instead of 27, I'm just going to write that as 3 cubed. So I've got 3 to the 1/4 times 3 to the, this would be 3/2. Just like before, we're going to add those exponents together. So we need to figure out what is 1/4 plus 3/2. Well, we don't have common denominators, so this would be 1/4 plus 6/4. So it'd be 3 to the 7/4 power. Now, some of you might be wondering, why didn't we evaluate that further? Well, we'd have to know what the fourth root of 3 is. And even if that was a clean number, raising that to the 7th power would be a nightmare. All right, 2 more, almost done. 6 to the 1/2 divided by 36 to the 1/3. Again, we want the same base, but we don't have the same base, so we're going to try to take the larger of the two, in this case 36, and write that as 6 squared, because you want to have the same base as your other term to give you permission to use our exponent properties. So I got 6 to the 1/2 over 6 to the, that would be 2/3 down there. Since I'm dividing, I need to find the difference, so I'm subtracting 1/2 minus 2/3. I need common denominators to do that, so that would be 3/6 minus 4/6, which is a negative 1/6. So my result here would be 6 to the negative 1/6 power. But we're not too thrilled about negative exponents, so we'd call that 1 over 6 to the 1/6 power. Final answer. All right, last and final one. 3 to the 1/4 divided by 27 to the 2/3. Bases are not the same, so we'll look at the larger of the two bases, 27, and ask ourselves, can I write that as the smaller base, in this case 3, raised to some power? And in this case, yeah, we can. That's 3 to the 3rd. So we have 3 to the 1/4 power over 3 to the 3rd to the 2/3 power. So if I clean this up a bit, this would be 3 to the 1/4 over, let's see, 3 times 2/3. That'd be 3 times 2, which is 6, divided by 3 is 2. So divided by 3 squared. Another way to think of that is the 3's essentially would just cancel each other out and turn into a 1. Just like before, we have division of the same base, so we subtract the exponents. I need 1/4 minus 2. They don't have common denominators, so we'll give them common denominators. I'll say 1/4 minus, let's see, if I multiplied by 4, that'd be 8/4, which is negative 7/4. The fact that it's a negative means we will end up in the denominator of a fraction. So I'll have 1 over 3 to the power of 7/4. Actually, let me rewrite that a bit, because that looks like it was 3 and 7/4. There we go. All right, folks, that is it for this video. Again, you know the drill. If you have any questions, do not hesitate to ask, and as always, good luck, have fun, be safe, roll tide.